Okay, so the final review video on our rational operations is going to go over adding and subtracting. So adding and subtracting are really kind of the same thing, except you're changing direction, right? If you're adding something normally on a number line, you would go to the right. If you're subtracting something on a number line, you would go to the left. Basically, it's like subtracting is just really adding a negative. So we're going to do it all in one video. Okay, so this would be like if you had a over b plus c over d. Or a over d minus c over d. Or a over b minus c over d. There we go. So anytime you're adding or subtracting fractions, the first thing you need is a common denominator. And you want the lowest one because we want to keep our numbers small. So you want your least common denominator. Or your lowest common denominator. This is the smallest number that both of the denominators go into. Okay, so in this case we have a b and we have a d. Well, we don't know what those are. Those could be anything. So the smallest thing that we know they both go into would be them multiplied together, right? So b times d, that's going to be our lowest common denominator. So then once you do that, we're going to do, kind of like when you cross multiply. So we look and we see what they're missing. So if we want both of the denominators to have a b and a d in the denominator, we need to see what they're missing. Well, this first one on the left has a b, but it doesn't have a d. So we need to multiply it by a d. But we can't just multiply it here. If we're going to multiply it, we got to do top and bottom. So we're going to multiply. On the right side, it has a d, but it doesn't have a b. So we're going to multiply a b, but again, you have to do top and bottom. And then you would just add it up, right? So in this case, let me move the subtraction one out of the way. It's kind of getting in the way there. Let's move that over here for a second. Okay, so here we have a times d over bd plus b times c over d over bd. So now our denominators are the same thing, so all we got to do is combine our top ones. So this is going to be a times d plus bc. And then the denominators don't add, they just stay that way. So this is like bd. And that would be our answer. So same thing with subtract. We see that they both have a b and a d, so our lowest common denominator is going to still be bd. So then again, we look and see what it's missing. This is missing a d, so we do the same thing. This is missing a b, so we do the same thing. And we end up with ad minus bc over bd. Okay, so that looks weird. We got letters everywhere. Let's look at some numbers. Let's say you want to add 2/5 plus 3/5. Ooh, no, let's make this real. Let's say you have a pizza. And we want to know how much of the pizza you actually ate, right? Okay, so here's your pizza, and you and your brother arguing over who ate more pizza, because now all the pizza's gone. Okay, so here's our pizza. Okay, so first you had a plate, you ate 2 slices. And then you went back for seconds because you were super hungry, and you ate 3 more. Well, our pizza was divided into 8 sections, right? 8 pieces. So your first plate, you had 2 over 8. Or 2/8 of the pizza. And then your second plate, you went back for more, you had 3/8 of the pizza. And your brother's saying, you ate more than I did. And you're trying to tell him no, but I mean, we could look and we could see, yes, you ate more. But, okay, let's see how much of the pizza you ate. Well, so our denominators are already the same thing. They both are an 8. So all we have to do then is we just add up the top. So we have 2 plus 3 gives us 5 over 8. You ate 5 slices altogether, so that's 5/8 of the pizza. Okay. But, so let's say our fractions were different. Let's say you had 2 over 5 plus 1 over 5. Oh, no, let's make it different. 1 over 3. Okay, well now this isn't as easy. We can't just say 2 plus 1 anymore. And we can't go 2 plus 1. So we can't go, okay, this is 3, and then 5 plus 3 is 8. Oh, look, it's 3/8. No, that's not right. We can't do that. Wrong. Okay, we got to do it the right way. So we have 2 over 5 plus 1 over 3. Our very first thing that we need to do is we need a common denominator. Well, the smallest thing that 5 and 3 will both go into, like the smallest thing they'll multiply to make, is 15, right? Because your multiples of 5 are 5, 2 times 5 is 10, 3 times 5 is 15, 4 times 5 is 20. So you do your multiples of 5, you do your multiples of 3. The smallest thing that they would both go into would be 15. So your common denominator is 5 times 3. That gives us 15. So then we look and we say, okay, well, we have 2 over 5. We want this to be a 15. So the thing that we would need to multiply by to make that a 15 would be a 3. So we multiply 3 over 3. On the right side, we have a 3, we're missing a 5. So we would multiply 5 over 5. So now we multiply the top, so 2 times 3 is 6. 1 times 5 is 5. All of this is over 15. Then we combine our like terms, so 6 plus 5 is 11, so our answer is 11 over 15. Okay, so you've been doing that since elementary school, we're good on that. Let's do it with some letters. Okay, let's say we have this. Let's say we have 1 over x plus 3 over x plus 1. Okay, so this looks a little bit different. We can't just say, oh, well, they both go into 15. We don't know, right, because x changes. So in this case, we're going to find our lowest common denominator, but the only thing we could really do is we could just multiply the denominators together. This is going to be an x times x plus 1. So then if we look at it, the one on the left is missing our x plus 1, so we multiply times x plus 1. But again, we have to do it top and bottom. The one on the right is missing our x, so we do our x. And now we have to distribute. So we have 1 times these. Well, 1 times anything is just itself. So that gives us x plus 1 plus, and then 3x. And all of that over our common denominator, which is x times x plus 1. Our last step is to combine our like terms in the top. So we have an x and a 3x. That makes 4x. And the 1 is just by itself. So we have 4x plus 1 over x times x plus 1. And that's our answer. If we do a slightly more complicated one, we write out our steps. Again, our first step is always going to be to factor. So, step 1, factor. Step 2, you're going to find your lowest common denominator. Step 3, you're going to multiply by whatever it's missing, by whatever you need to do to make the LCD, by missing. And then step 4, you're going to add or subtract the numerator depending on what you're doing. So add or subtract numerators. And remember, numerator is just the top part. Okay, so let's say we have x squared plus 5x plus 6. Oh, no, let's put that in the bottom. Okay, let's say you have x plus 1 up here. Now let's say you have x squared plus 5x plus 6 plus 3 over x plus 2. Okay, so the first thing we'll do is we'll factor. We've done this x squared plus 5x plus 6 before, so we already know that this is going to factor into x plus 2, x plus 3. I'm not going to go through factoring it every time because we already know how to do that. This is x plus 1, so that we just factored. And then we have 3 over x plus 2. Okay, now comes the good part. So, we notice that on the left we have x plus 2 and x plus 3. On the right we only just have an x plus 2. So we need, our lowest common denominator has got to represent both of our terms. So our lowest common denominator is going to be x plus 2, x plus 3. Because we need both of those. And because we need both of those, we have to now look at both of these terms and see if they're missing anything. The one on the left is not missing any of these. It has the x plus 2 and it has x plus 3. But the one on the right only has x plus 2. It's missing our x plus 3, so that's what we're going to multiply by. And when we do that, now we're going to distribute. Okay, so if we rewrite, we have x plus 1 over x plus 2, x plus 3. That didn't change. We didn't have to multiply that by anything. The other one changed, so now we have plus 3x plus 3, plus 9, right? 3 times 3 over x plus 2, x plus 3. And then, so we're going to add straight across. So our numerators are now, let me rewrite this. This is x plus 1 plus 3x plus 9. And all of that over our x plus 2, x plus 3. Then we have some common terms. So we have an x here and we have a 3x here. So x plus 3x gives us 4x. We have 1 on the left. We have a 9. Those add together, so 1 plus 9 gives us 10. So we have a 10 here. And this is x plus 2, x plus 3. Now the only thing left to do is we could simplify. If we wanted to, both the 4 and the 10 are divisible by 2. So we could pull a 2 out. It may or may not help us. This would end up being 2x plus 5. So in this case, it didn't actually help us, but that's okay. It's more simplified. So, or further simplified, if you will. So that would be our answer. Now the only difference, like if we were subtracting, the only difference is that instead of adding, instead of adding right here, if we were subtracting, we would have distributed, when we multiplied, we would have distributed a negative 3 instead. Right there we were adding, but if we were subtracting, it would be negative 3 times x and negative 3 times 3. So we would have had a negative 3x minus 9. That's the only difference between adding and subtracting, is just the sign changes. So then we would have had like x plus 1 minus 3x minus 9. So it would have ended up being like negative 2x minus 8 on the top. Okay. That's it for this one.